everyone. Chapter 1, Learning Target 7. This is the last learning target. This is Miss Oshier.
And Miss LaHart.
And here we go. We're sketching functions.
I love a good sketch.
Now, we are fully aware that you have access to a graphing calculator. However, we expect you to be able to do this without that graphing calculator. So just throwing that out there first.
Yep, you might have to be able to do it.
Okay, so you need to determine the end behavior, plot the y-intercept, and completely factor, choose a test value. We got all this stuff to do. When it's in factored form, end behavior is a little tricky. Not too much, but we got to pay attention. So we need to figure out the degree. You only have to add up your exponents when it's in factored form. If it's in standard form, whatever your highest degree is your highest degree. So 3 plus 4 plus 1, don't forget about this 1, is 8. So we know that this is an even degree function.
Yep.
Which means it's going to start and stop in the same place.
It's going to end up or end down.
End up or end down. So then we look to the leading coefficient. It's positive, so we know that it is starting and stopping.
Look at us already have a
Going
heading.
up.
We already have a heading in this. Step 2 is, I think, find your y-intercept. Oh boy. So the y-intercept is on your y-axis. What is your x value? 0. So plug in 0. But don't just think it's just going to go away, because you actually have to do some math. Negative 2 cubed is negative 8. 1 to the 4th is 1. Negative 4, yeah. And there's your y-intercept.
Boom, boom, boom. So we know 0.32 is our y-intercept. Now remember, this is a sketch, so you don't need to have a beautiful scaled interval.
32.
It's a sketch.
Don't do it.
Nope.
Okay.
Nope.
Just go by the same interval. Don't start by going by 5s and then switch to 10s.
Right. No, don't do that.
Even intervals.
No. So you can just say, hey, that's 32, and that's fine. All right, now we're going to completely factor to find all real zeros. In this case, it is completely factored. But we do need to say what the zeros are and their multiplicities. So our zeros are 2, negative 1, and 4. Multiplicities, so right, we plot those on the x-axis because those are our zeros. And then multiplicities, I'm going to talk about later, apparently, when I start sketching them. But remember, this is going to mean it goes through, but it slows down a little bit. This is going to touch, but it's going to go a little slow. It's going to flatten. And this one is going to cross straight through.
Now some test values.
So test values are literally that. You just find values on the outside and in between your real zeros. We are going to want at least 5 points total on your graph other than the y-intercept.
We need to see the flow of the graph. If it's not very good, trust me, we won't give you full credit. So we plug in negative 2, we pop out a 384. Plug in a 1, you pop out a 48, a 3, a negative 256.
So again, the scale does not matter, because as you can clearly see, 32, 384, we're just sketching, okay? But we have those points listed, so we know that it's coming in pretty high before it comes down. Okay, we got a flow.
Yep.
And now here's where the multiplicities come into play. So when we graph this, we're crossing, but we're flattening a little, because it's not 1. We're flattening a little, and we're crossing. So now come the beautiful sound effects. So when you sketch, you're coming down at negative 1, you're touching, you're flattening out a little, boop. Oh, okay, it took a little while. And then we gotta go through the y-intercept. This is where the test point matters. We know to go up before coming back down. So we went up, now we're coming back down, and we're flattening a little, and whoosh. And then we're coming down, and we're going whoosh, through.
Yep. Make sure you have your arrows at the end to show that it continues. And look how beautiful that thing is.
It's really nice.
Correct.
We're going to go a little bit faster through this example. So again, we find the degree of the function. This would be 5.
2 plus 2 plus 1.
Negative leading coefficient. So
Ends down.
Ends down.
Ends down.
Boom.
Rounding. Boom.
Because it's odd, starts and stops in different directions.
Okay. Zeros, we plug in 0, we end up with 216. That's the y-intercept. She's going to extend our y-axis a little bit. Nice job.
Thank you. Because that will happen. You might have to erase and be like, oh, just kidding. I'm going to go way up
Use
here now.
Use pencil, my advice.
Oh, yes, use pencil. Zeros, plotted. Determining test points. Notice I only do 2 this time, because I really only need 2 in this circumstance, because I know I'm coming in from positive infinity. So 2 test points is fine. You want them in between your zeros.
There you go. All right, and now we just talking about multiplicities. At negative 3, it's going to touch, cross, and touch.
Boom, boom, boom.
Through those roots.
So we come down. Boop.
That was a touch.
Boop.
That was a touch. That was a cross.
And it's all from those multiplicities, people. Okay, this one takes a little bit longer. Sorry that it's got distorted. Deal with it, okay? This is different because it's not in factored form. It's also different because this can't be factored as is. Whenever we give you something like that, we will give you a 0.
Yep.
Because otherwise you would need a graphing calculator to be like, oh, what's going on here? Okay, so if we give you something like this and we say, okay, that is a 0, You can either do long division, which we're going to show as an example in this video, but we highly encourage you to do synthetic division because it's so much faster.
Right. You're trying to get it to a smaller trinomial that you should be able to factor.
So if you do long division, and again, we're not showing you the process because that's in another video, you get this, okay? The whole purpose of us doing that was so we could have a quadratic function because we're very good at factoring those.
Oh, baby, yes we are. We can take out a 2 and then factors of 3 that add to give you 4, 1 and 3, and look at that baby.
So this is our function in factored form. You want to remember not to lose this guy. This guy stays. That's why I wrote him all the way down, or her, depending on, I don't know, okay? All the way down, and there's our function. So now we can continue on. We're gonna get our y-intercept.
That one was really easy because remember, in standard form, it's just the constant.
Yep, there's benefits, you know, there's positives and negatives to everything, pros and cons. We know it's a third degree, so it's got a positive leading coefficient. Woo! So
here we go.
Look at us go. You know, it wouldn't be a video unless my computer did that. So
So we were at third degree.
Oh,
look at it right there.
Okay.
So we know that it's going to end up.
Third degree, yes.
Start down.
I think that's behind there. It's hiding on us. But
some test points, probably.
So now we're finding test points. So I did f of -2. I found 5. And then I should have, by all rights, well, we have 1, 2, 3, 4, 5. So we do have the minimum amount of points, but you should have another test point between -1 and 1/2.
Yep.
But for the sake of the video, we just did it real quick. So really the only difference is that when it's like this, you have to factor it.
Yep. And then you start sketching.
Have a wonderful day. Pencil, 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 people.